In 12.2, we will add and subtract polynomials. So today we're going to talk about adding, and then we'll do some subtraction tomorrow. Adding, we have two methods that we could use to add polynomials. One of them is vertical, so the other one is probably, say it louder, horizontal, right. Okay, so the little tip to adding polynomials vertically is arrange like terms in columns. That's the tip. So we want to be paying attention to which terms are like terms. The first expression has 3 terms. So we would call it what kind of a polynomial? Trinomial. Say it, everybody. Trinomial. And the second expression has 1, 2, 3, 4 terms, so we call it a 4-term polynomial. Very boring. Okay, so now we're going to do you want to align the first expression under the second one, or would you like to align the second one under the first one?
First under second.
Why do you say that, Ryan?
Because there's more numbers in the second one.
There are more numbers, there are more terms, basically, in the second expression. So he thinks we should align the first under the second. Who would like to do that? That makes sense, really. We usually add shorter numbers under longer ones, don't we? The same is true for polynomials. So we have a 4-term. We could even leave that right where it is and just take each of the terms in this first trinomial and align them under their like terms over there in the second. So 5x squared would go under what?
2x squared.
The like term, good. So we have a positive 5x squared. Over here we have, what do we have here? What is this term called?
Negative 2x.
Negative 2x. So we're going to align it under
Negative 5x.
negative 5x. Negative 2x. Okay? And then we have this 3. It's a constant. And we align it under 1. So we have a positive 3. Remember, we're adding all this together. Okay? So we could start from the right, like we do with numbers. We could even start with the left, because we are not going to carry anything, are we? An x doesn't become an x squared when we add it. It just stays an x. We just add these like terms. But let's start from the right, since we're used to that. 1 plus 3 is?
4.
That's a positive, right? We have negative 5x plus negative 2x.
Negative 7x.
Good job, negative 7x. And we have 2x squared plus 5x squared.
7x squared.
Good, 7x squared. And then we have x cubed plus no other x cubed. So what do we have?
X cubed.
We have a positive x cubed. Right, so 1x cubed. This is an x. Okay? And is there any other way we could simplify this expression? Are there any variables to the same degree here?
No.
No, so it's done. That's it. We did it vertically. Okay, so we're going to go ahead and add this vertically too right now. So go ahead and try. It's a little tricky because these expressions have variables to different exponents. If we move the first trinomial underneath the second one, Max, where would I move 6x squared? Underneath which term in the second?
4.
Good. Put it right under the 4x squared. And we're adding it, right? Plus 6x squared. If I move the negative 3x, where would I put it under the second term? Under the negative 5. Negative 3x goes under the negative 5. And if I move this 1, where do I move that? Lauren?
To after negative 3x, because
There's no constant term in the first trinomial. So it would come to the far right, so let's put it on the far right is what she's saying. That makes sense, okay? So when we add this up, if we were to start from the far right, we have nothing here. We could represent that as plus what? Plus nothing, plus 0, right? So we have 0 plus 1, which is 1. It's a positive 1, isn't it? So then we have negative 5x and plus negative 3x. What is negative 5x plus negative 3x? Negative 8x, good. And then we have 4x squared plus 6x squared. Dylan? 10x squared. And then we have 3x cubed plus no more x cubed. So what do we have? 3x cubed. Good. And that's in standard form because the highest exponent is first. Okay, we're going to try it horizontally then. And when you are given expressions written horizontally already, then you probably will love this method because you don't have to rewrite anything. You leave the terms where they are. But you do have to do a little bit of accounting. You want to make sure every term has been included in your simplified expression, right? Okay, so if we start with the left side here, 4a squared, we simply look down across this whole expression and say, are there any other a squareds? And are there, Charlie? And so what are we going to add to 4a squared? 7a is not an a squared. 2a squared. Good. This one is like it. So what is 4a squared plus 2a squared? Good. Okay. And then we look at the next term and we have negative 7a. Rachel, what could go with negative 7a?
Positive 3.
And what do you end up with?
Negative.
Negative 7 and a positive 3.
Negative 4a.
Good job, negative 4a. And then we have 4 and a negative 4. And Faith, what is that? Did I say 4? 5 and a negative 4. And what do we have? Which one's more? Which one has a greater absolute value? The 5. So it's positive 1, right? Positive 1. Okay? Good. And we can no longer combine anything because these are different terms. As I was just saying, this is like having 6 iPads and take away 4 iTouches. They're not the same thing. Plus 1 screen cover or something. It's not even an iPad. Okay? It's not even a device. It's just an accessory. One little blingy accessory. Okay? Try these two and then come back and check. Horizontal. Horizontal. We're just adding these. So who chose to just leave it horizontal? Did anyone rewrite it vertically? Okay. And when you're doing your assignment today, writing it in columns is vertical, right? If you see it like this in the assignment, in the book, you can always write it vertically. Not even write it this way. Just go ahead and stack like terms underneath like term. Bianca, this is how many y squareds here?
1.
So the coefficient, that should be right next to it, is a 1 there. There's a 1 y squared. And then how many do we have over there?
2. Negative 2.
Negative 2. So what is 1y squared and a negative 2y squared?
Negative 1.
Negative 1y squared. So we can even write that as negative y squared, right? And then we have, what do we have here?
Minus 1.
How many of them are there? 1. Minus 1y, and we have,
Plus 2.
so what do we have in all?
We have positive 2. I mean 3.
Negative 1y and a positive 2y.
Oh. Positive
2y.
1.
Good. Positive 1y or positive y, right? And then we have a 1 and a negative 1. So what do we have?
We have 2.
1 and negative 1? They're opposites, so nothing, right? 0, which we could leave as not writing anything. So here you have, what is this called? Based on the fact that there are 2 terms, this is a binomial. Good. And then number 4, who have I not heard from? Nick.
Should I say the answer?
Go ahead and say the answer.
I got 4p squared minus 5.
Thumbs up if you agree. 4p squared minus 5. Very good. And that's because a negative p and a positive p are opposites. Negative 1, positive 1p, opposites. And then 3p squared and 1 more make 4. Okay, very good. So here's your assignment. You may begin.